So let's start the paper. Okay, so the first question is about kinematics, in which we will be initially defining acceleration and then using equations of motion to solve the next questions. Then we have a collaboration with the energy formulas, in which we will be finding kinetic energy, potential energy, and related to that we will be finding frictional force in the object. Second question initially wants us to simplify the given formulas so that we can prove that it actually is applicable in certain situations. In its next part, we have to use a graph and to perceive what they are asking us, and next we will be using it to calculate the density of the liquid in the cylinder. So basically these formulas are usually used and they shall prove very helpful. Now the next question is related to elasticity, in which we will define the Young modulus, for which writing the formula is enough. Then we will be using again proving using the ratio formula to further simplify and find out the correct answer. Now for this question we must be really careful. So as the Young modulus differs for each of them, we must remember that for both of the wires, the force and extension will vary at differently. Okay, not the same. Again over here, next we have the question related to the waves, and for this question we shall first differentiate longitudinal waves and transverse wave, which are related, which differ mainly due to wave motion and direction of vibration. So again, this next question is related to simplification of the formulas, but this time we have their SI units. Further simplifying them allows us to find the correct answer. Next part relates us to the Doppler effect, which is related to the frequency of a moving object or a stationary object and its velocity, if it is approaching us or not, or going far away from us. So in this sense, basically the Doppler effect usually has this one formula. So applying it usually allows us to solve the questions very easily. The next question is related to light, in which we will be first identifying diffraction and interference. So after doing that, we will be using the formula d sine theta is equal to n lambda to solve the further questions, and in which step by step we can finally get the number of lines per millimeter. Here you must be really careful. Your concept should be really strong, that the d in this formula relates to the number of lines per meter, number of 1, or we can say that